plane and its equation. We usually think of architecture in terms of massive volumes, not planes. However, walls, floors, and ceilings that define these volumes are nothing but planes. A plane is a flat surface consisting of a set of infinite points in space. On joining any 2 points in the plane, the line formed lies entirely in a plane. A plane can be horizontal, vertical, or sloping. Think about what information you need to specify a plane in space. We know that to specify a line in space, we need a point on the line and a non-zero vector parallel to the line, which gives its direction. Can you consider a single vector parallel to the plane to define the plane's orientation or direction in space? There are infinitely many planes parallel to a given vector. But they have different orientations. Therefore, a single vector parallel to a plane is not enough to convey the direction of the plane. Hence, let us now consider 2 non-parallel vectors. We can see that planes parallel to these vectors have the same orientation. Thus, 2 vectors define the orientation of a plane uniquely. The vector or cross product of 2 such vectors gives a vector, and its direction is given by the right-hand rule. This vector is perpendicular to both the vectors. It is also perpendicular to any vector, or line in the plane, or parallel to the plane. This vector that is perpendicular to the plane defines the direction of the plane and is referred to as normal to the plane. It is denoted by vector n. A question arises whether it is sufficient to know the direction of a plane to uniquely describe it. In space, given a vector, there are many planes that are perpendicular to it. Therefore, in order to specify a plane, in addition to the normal, we need to specify one more piece of information, say, a point through which it passes. Thus, to find the equation of a plane, we need to know normal to the plane and a point lying in the plane. Let us now find the equation of the plane when normal to the plane, vector n is equal to ai cap plus bj cap plus ck cap, and a point A with position vector A is equal to x1 i cap plus y1 j cap plus z1 k cap are given. Let P, x, y, z be any arbitrary point in the plane with position vector r is equal to x I cap plus y j cap plus z k cap. As the vector joining the points A and P lies in the plane, the normal, vector n is perpendicular to the vector AP. That is, the dot product of vector AP with vector n is equal to 0. But vector AP is equal to vector r minus vector A. Therefore, dot product of vector r minus vector A and vector n is equal to 0. Or, this is the vector equation of the plane. Let us find the Cartesian equation of the plane. Dot product of vector r minus vector A and vector n is equal to 0. Substituting for vector r, vector A, and vector n, and simplifying, we get A times x minus x1 plus b times y minus y1 plus c times z minus z1 is equal to 0. or ax plus by plus cz plus d is equal to 0, where d is equal to minus ax1 plus by1 plus cz1 is a constant. This is the Cartesian equation of the plane. Now, let us find the vector as well as the Cartesian equation of a plane, passing through a point having position vector 2i cap plus 3j cap minus 4k cap and perpendicular to the vector 2i cap minus j cap plus 2k cap. Here, vector A is equal to 2i cap plus 3j cap minus 4k cap, and vector n is equal to 2i cap minus j cap plus 2k cap. So, substituting for vector A and vector n, we get vector r dot 2i cap minus j cap plus 2k cap is equal to minus 7. Cartesian equation of the plane. On substituting the values of a, b, c, and x1, y1, z1, and simplifying, we get 2x minus y plus 2z plus 7 is equal to 0. Using the above method, we can find the equation of the plane under different conditions, such as given a point and a plane parallel to the plane, given a point and two planes perpendicular to the plane, given a point and two vectors or lines parallel to the plane, given the normal to the plane and its distance from the origin, equation of a plane in normal form, given three non-collinear points. In all these cases, we will first find normal to the plane and find the equation of the plane. Summary: a plane is a flat surface consisting of a set of infinite points in space. On joining any two points in the plane, the line formed lies entirely in the plane. The vector, that is, perpendicular to any vector or line in the plane or parallel to the plane, is perpendicular to the plane and defines the direction of the plane. It is referred to as normal to the plane and is denoted by vector n. To find the equation of a plane, we need to know normal to the plane and a point lying in the plane. We have learned to find the vector and Cartesian equation of a plane given a point and its normal. Moreover, we can find the equation of the plane using the above method, finding the normal to the plane under different conditions.